All right, so here, this is an anatomy of a sampling distribution through StatKey. And I do have a page dedicated to this on the course homepage. You should check out. This is also in the book. So again, important things is one, I have to have the right sample. That's supposed to say sample right there. And then two, I've got to generate thousands of samples. And then three, I select two tail. Usually we'll stick with the 95% in the middle. And then what we want to do is we want to identify, and it looks like I cut that off a little bit, the lower and upper numbers. So here it looks like the lower one is 98.050, and the upper one appears to be 98.475. So that's my confidence interval. So based on this, what I can say is, based on a sample of 50 adults, the average body temperature of an adult in the US is somewhere between 98.05 and 98.475 degrees Fahrenheit. Question, what do we usually believe average body temperature is? 98.6, is that in this interval? It is not. 98.6 is out here. It's not in my confidence interval. Okay, so either I have a strange set of 50 humans, or 98.6 isn't actually the average body temperature of humans. Things to note, average body temperature is complicated. Our temperature changes on average throughout the day, and different parts of our bodies inside have slightly different temperatures. Like the temperature of your brain is not exactly the same as the temperature going on in your stomach or leg muscle or bone, for example. But on average, we say it's about 98.6. This data for this set of students says, now again, what's the average for this group of students? It's 98.26. That happens to be about the center of the interval on the confidence interval. Okay. Typically, we use this number as the center, not that one. So here's your next goal. Tell me what the margin of error is here. You're going to need a calculator for that. What's the margin of error for this particular sampling distribution and confidence interval? And the way I recommend you to do it early is take the upper number, subtract the lower number, and divide by 2, right? Half the distance. Anyone got a number for that? It should be smaller than that.
About 0.2125.
0.2125. Anyone else? Okay, so 0.2125. So 0.2125 what? That would be degrees Fahrenheit. So a couple things we get from this sample. One, we think average body temperature is about 98.26. Margin of error on that is about 0.2 degrees Fahrenheit. So we think the actual population one could be about 0.2 degrees higher than that, or about 0.2 degrees lower than that 98.26. Another thing we could say is we think average body temperature is somewhere between 98.05 and 98.475. What's our confidence level here? That's the 0.95 in the middle, 95%. So this is a 95% confidence interval. The 95% rule we talked about before, what's the other name for that? The two standard deviation rule, remember? Okay, so notice that if you take this standard error here and you double it, then you're going to get 0.216, which is similar to what StatKey says the margin of error is. And I mentioned that earlier. At this point in time, we have two ways to calculate margin of error. We can use a sampling distribution to come up with a standard error and then double it if we're using a 95% confidence level. Or we can have StatKey count what are the boundaries for the middle 95% of resamples, right? And there's a whole bunch of dots here. Each dot on this screen is another sample of 50 drawn from the original sample. It's complicated. But this is the way statistics is done these days using these kinds of simulations. And our goal is to just keep getting used to how the technology does this for us and what do these things mean. So again, summary of the big ideas. We are estimating population proportions using sample statistics. And we're just sticking with two kinds of statistics and proportions. The proportion or statistic that I'm going to play with is either a mean or a proportion, but you could do it for any kind of statistic, a median, a quartile, a standard deviation. Anything you can calculate for descriptive statistics, you can try and estimate for the population. Because of sampling variability, this estimate's not going to be quite right. That means every sample is a little bit different. Because of that, we then have to come up with an interval estimate. Oops. And or margin of error. And the relationship between the sample statistic, the margin of error, the interval, and the proportion can be summarized in just a little picture. Okay, so we were just playing with a mean. The sample mean goes in the middle. Sample mean is X bar. If we then add to that twice the standard error, that gives us our upper value. And if we take that sample and we subtract twice the standard error, then we're going to get our lower estimate in the interval. Right? So with some estimate of what we think the population is doing, the statistic predicts what we think is happening with the population parameter. What's the population parameter here? It's a mean. Mean of what? Maybe it's mean salary. Maybe it's mean BMI. Sample helps predict what the population might be, but it's a sample, so it's not quite right. So we have to expand to an interval. And then from that interval, we can pull out a margin of error. And the margin of error is the distance from the center to the edge if it's symmetric. And we think the population mean is somewhere in there. Are we sure? No. Anybody remember the symbol for population mean from a couple weeks ago? It's a funky looking U thing. It's a Greek letter called mu. So in this case, my sample statistic is X bar, sample mean, and the population parameter, that should say parameter, sorry, parameter, in this case, related to the mean would be the mu. And we think mu is somewhere in here. Maybe it's here, maybe it's there, maybe it's there, maybe it's not. But we think it's somewhere in that ballpark. Okay, so this is the relationship between the sample statistic, confidence interval, the margin of error, and the population parameter. And again, we just got to keep getting used to this whole process and how these things are related. We're going to do a bunch more of this next class. And for the rest of the term, we're going to do this kind of thing.